Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the first episode in the C++ for Java/C# developers. Now, in this episode, we are going to be creating this riveting program, which says I'm thinking of a number between 0 and 100, and you can make a guess, and it will tell you once you get it correct. And so then it'll tell you if you got it or if you didn't, and you can hit yes to play again and hit no to quit. So, while this program is very simple, it's a really good first step for learning C++. Now, before we actually begin learning C++, what am I assuming you already know? I am assuming you know what a for loop is. So if I were to do this, I assume you know how many times this loop would iterate and what it would do. I am also assuming you know what a while loop is. So I'm assuming that you know if I coded something like this, this would never finish. I'm assuming you know what a do while loop is. So I am assuming that you know that this is just a variation of the same thing we did just a second ago. I am assuming you know what an array is. So if I code something like this, I assume you will know that that is an array full of 100 slots for integers. I also assume that you know what basic types are: int, float, bool, all these different things, and I hope you know what that is because we will be using it a lot. I'm also going to assume you know what a function is. So if I create something like this, I assume that you know this function returns nothing and takes in one parameter called a. I will lastly assume you know some basics about object-oriented programming. So if I created some sort of class, dog, this encapsulates some behavior in something called a dog class. Now, these are the only things I'm going to assume you know, okay? If you don't know these things, I would suggest you learn them before starting this course because it will not make sense to you. Now, let's jump right into it. So I am going to be showing you guys how to compile a C++ program from the command line and then execute the program that you generate. We will be doing this in Windows for now. I will cover Linux in the next tutorial, and Mac should be very similar to Linux. Unfortunately, I don't have a Mac machine, so I can't actually test that. But if you go to Microsoft's documentation, which I will have a link to this in the description, they have this article using the Microsoft C++ toolset from the command line, which tells you all about how to use these things. There's another link in here, which I will also have in the description, which is particularly useful for us. If you want to just be able to compile C++ programs, you need the MSVC compiler, which you can download right here. So if you just go through, download this whole thing, you should end up with a program on your Windows machine called Developer Command Prompt for VS 2019. Now, if you just search for that in your search bar and actually execute this, you will find it. It should be located somewhere like Program Files x86, Microsoft Visual Studio 2019 Community, or somewhere similar for your program. This basically gives us the tool sets so that we can actually compile programs. And if we type in cl-help, then you should get a bunch of different compiler options that you could use. This means that you've installed everything correctly and you basically have nothing to worry about, okay? Now, I'm gonna leave this open for now because it will be useful for us. Let's talk about how you can actually build a C++ program though. And it is called a build process because there's quite a few steps. I'm gonna go ahead and open a new folder in here. So I would suggest you put your folder somewhere like C, dev, and then I have a C++ folder, and we'll call this C++ for Java devs. Now I'm going to open this folder up inside a new window inside of Visual Studio Code, and we'll just go ahead and hit Control-N to create a new file. Save this in there as main.cpp. Now you'll probably want to install some extensions for C++. So the C++ extensions that I have installed are this one right here, C++ 1.2.2. Then I also have CMake and CMake tools, which we will be using a little bit later. I would also install this hex editor, which we'll be using, and that should be it. This one is the most important one though, C++, and I'm not going to be staying in Visual Studio Code for the longest time, so it's not too important if you can't find these extensions. Now we've got this main.cpp, and basically what we want to do is create a program and run it. So the basics of C++ work something like this. If we just code in #include stdio.h, and then we go ahead and say int main printf, and you'll see up there it says const char star const format. Ignore that for now because we're not learning about pointers yet. We'll say hello world right here /n to give us a new line, and then we will return 0. So this is the most basic of programs that you can write in C++. Now, what does this hash include do? This is basically the same in Java as if you were doing an import, okay? But it's a little bit different. Hash include literally just pastes whatever code is in here into your file. So if we were to click onto here, so control click, you can see we get this massive file with a bunch of stuff that you probably don't know, that I don't know. And then if we were to just copy this, and then if we were to paste it over this is completely equivalent to what happens when we actually compile. I'm not going to do that because that would just be a mess. But that is exactly what will happen when you do a hash include, okay? So we're basically including those function definitions into here. So how do we actually execute this program? Well, I hope you still have your developer command prompt open. If you don't, reopen that real quick. Then we'll go back into our folder. I'm going to copy where we created that folder. So C++ for Java devs. Just click up here and copy this. And then we'll hit CD and paste that. And this should change our directory into this directory. Now let's go ahead and write out the most simple thing you can do, which is cl main.cpp. What this basically says is use the program cl to compile our main.cpp file. If we hit enter, we get a few different things, and it says we created this /out main.exe and we created this thing main.obj. Now, if we look inside of here, what do we have? Well, we have this main.obj and we have main.exe. So it basically just compiled our program for us, which is pretty cool. If we actually go ahead and type in main now, and then we type in main.exe, then we get hello world printed. And this executable can be put on any other Windows machine that you have. So if your friend has a Windows machine, you can simply copy this. And if you copy this to their machine, they should be able to run hello world. It might give them an unsafe executable, which they have to say run. I know this is safe, but it will work out the way you think. Now, typically when you're building something, you don't want to fill up your main source directory with all this junk, right? Because these are outputs. If we delete this, we're perfectly fine because we can always rerun cl main.cpp and it regenerates these files. So I'm going to go ahead and delete these, and we'll create a batch script to do a little bit of housework for us. So we're going to call this build.bat for batch. And if you don't know batch, it's fine. Every time I need to know something about batch scripts, I basically just look up what I'm trying to do and you can find it. But the basics that we will be using are just copy. Actually, we're not even going to be using copy, but move, push D, which pushes a directory, pop D, which pops a directory, and so on. So we're going to say if not exist bin. So bin for binaries. Then we basically want to say make directory. So mkdir bin. And then we're going to say if not exist bin-int make directory bin-int. Okay. So if we just run this batch script real quick, if we say build, okay, first of all, we get it printed out here, which is kind of annoying, and we'll turn that off in a second. But then if you look into your directory, you should see we get bin and bin-int, which is nice. So if you don't want it to print out that stuff every time you hit build, that's fine. Just type in echo off, @echo off, which basically says don't print anything I'm about to do. Okay, next thing we're going to say is push directory bin-int. And then every time we push directory, we want to pop directory. What this basically does is it changes the directory to this one, and then when we pop, it changes us back to our normal directory. So what we'll do is we'll say cl inside of here, and we're going to say // main.cpp. So now if we were to run build.cpp, I'm going to do cls to clear the screen. If we type in build, then you'll see it generated a exe and an object once again. And if we look inside of bin-int, they're in here instead, which is great because now we can just delete these two folders and we delete all those intermediate files. However, object files are intermediate, executable files are the ones that we actually want. So after we pop the directory and we're back out, what we're going to do is say move bin-int / main.exe to bin/main.exe. So we're basically just going to move our executable, which is the thing we care about, into our binaries folder, the bin folder, because that is where we want that one to live. So now if we run build.batch one more time, we should go ahead and see that inside of bin, we have our main.exe. And then if we were to go ahead and say bin/main.exe, then we get hello world printed out. All right, cool. So this is a sort of very simple compilation process or build process using just batch scripts. Nothing fancy, no build tools, which I think it's important to know exactly how your build process works. Let's go ahead and make a little bit more of a complex program. So if we go and say printf, this is a float, and we'll do %2.3f. This is the same as a print format in Java or a print format in C#, or a string format, I should say, in C#. Now we can put in a floating point number. So if we do 3.1457f, that's probably completely wrong. I don't know pi. But basically, if we put this in, and we also want a new line there, this will print this number up to 3 decimal places and just drop the last bit. So it won't round up because this does not do any rounding. It's just formatting, and we should see 3.145. So then if we were to go ahead, build, and then we go ahead and run the executable, we see this is a float 3.146, and it actually does round. I was not expecting that. Okay, so yeah, but this is basic print formats, and it does everything you would expect it to do. You can do %d for data, which is basically if you have a number or anything that you just sort of want to print. You can do %s for a string. You can do %c for a character. You can do %u for an unsigned number, and so on and so forth. There's a lot of different format statements. If you want to look at them all, I would suggest looking up printf C, because this is more C than C++. Anyhow, let's look at some control structures. So if we go for int I equals 0 until I is less than 10, I++, and we go ahead and say printf %d, and then we'll say I, and then we should see the numbers 0 through 9 pop up. Let's run this real quick. So we'll build, then we will run the executable, and there we go. We see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We didn't include a new line, but we didn't include a space. That's why they were all spaced out. All right. So you should be very familiar with all this. I'm assuming you know the basics of programming. If we were to say while I is less than 10, I++, and then we were to say printf %d, I, and we define I up here to be 0, then this will print the numbers 0 through 9. It is exactly as you would expect it to be. There's no trickery here. It's pretty similar to Java and C++ in this regard. If you wanted to create a function, add, and you wanted to take an A and B, and you said return A plus B, it works exactly as you would expect it to, right? I'm not even going to compile this. You can do that for yourself, but this is all very simple stuff, and there is nothing unique about the way C++ does this. It works just the same way. One thing I will note, if this add function is below the main function is not able to see it, so it will not be able to call it. And we'll talk a lot about this in future episodes, but for now, just know that if you want a function to be visible, then make sure it is defined above the function that calls it. Okay, last thing we're going to talk about real quick, and then I'm going to give you a challenge, is how do you get input, right? How do you get input from the terminal? Well, we can use scanf, all right? So if we were to do scanf, and we say we want to take in a number, so I'll do %d, we want to put it in some number. And so the syntax for this is a bit weird. Right now, what I'm going to do is ampersand var for variable. And we'll go ahead and say int var. And what we'll do is right before we take that number, we'll say printf input a number colon, and I'm going to leave the new line off. So what this is going to do is it's going to print put a number. This is going to consume a number from the input and ignore the ampersand. We'll talk about that in future episodes too, but this will basically put that number into this variable. And then if we were to say printf /n, you entered %d var, then this should print out, and I'll do one more /n here, exactly what you input. So if we go ahead and clear this, build, then we say bin/main. It says input a number, I'll put in 15, and it says you entered 15. All right, so that's pretty straightforward. This is how you would input numbers. If you wanted to input a string, you would have to allocate some memory on the stack, which is fine. Okay, don't get scared. So if we just said string buffer 100, then we could do that. And then we would say use this string buffer. %s is what we're taking in, and we'll say input a string, and then change this to string buffer here, and we'll just say %s. This will allow you to put in up to 100 characters, right? Because we define it as 100. If you put in anything over that, it's technically a buffer overrun and you may or may not get an error. So if we were to go ahead and say build, and then we were to run it, we should be able to put in hello world. And it says you entered hello. And this actually brings up something interesting about scanf. The way scanf works is if it encounters any white space, then it just sort of terminates and accepts that as the string. Now, if you wanted to accept that whole thing, what you would have to do is say string buffer1 here. We'll copy that, say that this is string buffer2. And then if we pass in string buffer1, string buffer2, this basically says accept a string followed by a space followed by another string. Then if we were to do this and print out both of these string buffers, we should see that we get hello world printed. And this is kind of a quirk and it's kind of annoying, but this is the way that it works, and we'll look at better ways to do these things in the future. So if we type in hello world, then you see we get hello world. Okay, so basically it will just terminate if you hit any white space and stop accepting input. Now, these are some basic ways to get input. I will show you one more thing, which is what if you want to create a random number. So if we hash include std_lib.h for standard library, then we get access to a function called rand. So if we type in rand, then you can see this returns an integer. And if you were to look up documentation on this, it basically returns any integer between 0 and I believe it is int max, which we can see is 2147, very big. It's basically 2 to the power of 32. So if we want to generate a random number, we can say int rand number equals rand, and we'll say mod 100 to get a number between 0 and 99. And you can use this however you want. If you want to seed random so that you get different random numbers every time you run the program, we'll have to include one more library, time.h. And then we can say srand for seed random, and then we'll give it time null. And basically this is a few different functions. Don't worry if you don't understand them. You can usually Google this stuff if you ever need information. This will basically just get the current time. Then it will seed the random number generator with that time. That way you get a random number every time you run the program. So we'll clear all this out real quick. Say random number %d, and I will pass in this random number. And if we go ahead and compile, so we build, then if we go ahead and run, okay, and I completely lost my train of thought because apparently Windows thinks that this program is a Trojan, which it's not. So if you are getting that error too, you can get around this by just going to virus and threat protection. And I guess it's a good thing this popped up. If you just go to manage settings, then you can go scroll down to controlled folder, or actually go to exclusions. And I just put in the folder that I'm developing into this exclusion, which should block any sort of those warnings you get. You should not have to worry about this code. We wrote it. It's fine. There's nothing in here that could be a virus that's going to attack your computer. But yeah, basically, now if we actually build this and then we go ahead and run this, then you see we get random number 0. And if we run it again, we get 10. And then if we were to run it again, we get 23. And it will change every time because we are seeding it with a random time. Okay. With those things in place, I want you to build a game like the one we saw at the beginning, where it will say that it's thinking of a number between two other numbers, and it'll allow you to make a guess, and then it'll tell you to guess lower or guess higher. And once you finally get it, it should say play again, and if you type in N for no, it should cancel, and if you type in Y, it should run the game again. So using everything that we just learned here today, I would suggest doing that. And one last thing that I will mention is if you want a custom name, say you wanted to call your executable something like whatever you want, I'll call it your name, then what you would have to do is type in /link with a /, then /out : and then I'm going to type in yourname.exe. You can type in whatever name you want. If we were to build this, then it builds successfully. And if you were to run it, it runs successfully as well. And we'll talk about what linking is in the future. Technically, you should have this at the end of your compile statement /link, because that is the proper way to compile a C++ program. We just didn't need to link to anything since we had one file, which is why it worked for us. That will be it for this tutorial though, guys. And in the next tutorial, I will go over my solution to the problem that we had, and then we will begin talking about more C++ language features. And we'll be starting simple with more of the C features and work our way up to C++. Anyways, I hope you enjoyed this. If you did, please hit like and subscribe, and I'll see you in the next tutorial.